In this video, we'll look at some nematodes, or roundworms, like these worms in the genus Cephalobus. Nematodes occur basically everywhere wet or even damp, and are easy to find in nature. But just to make things easy for myself, I bought some free-living nematodes from a supply company. These are being raised on what is basically rotting mashed potatoes, where they are eating the bacteria growing on the potato bits. Here are a few in diluted medium. The spherical objects are little bits of potato. Nematodes almost always wriggle in this particular distinctive way, so that even if you see them at low magnification, you can immediately identify them as nematodes. To see their anatomy a little better, I killed a few individuals by heating them up. Here's a male in side view. Males of most species of nematodes typically have a bent or hooked posterior end. They use that bend to grasp females when they're mating. The very anterior end is usually pretty blunt-ended. In this one you can faintly see the pharynx, which has two concentrations of muscles, or bulbs. That pharynx is used to suck in bacteria-rich fluids around them. That's what they're feeding on. Near the posterior end you can see a little bulge. That's the cloaca out of which the anus and the male gonopore open. Males have a set of copulatory spicules that can be extended out of that opening. Here's another male with a slightly more obvious set of copulatory spicules. They use those to help transfer sperm to females when mating. And here's a dead individual whose copulatory spicules are sticking out a little bit and are particularly easy to see. Females don't have that hook in the posterior end, and they also have separate openings for the anus and the gonopore. This female's anterior end is on the right, posterior to the left. In this female's posterior half, you can see two bumps. The posterior one is the anus. The one closer to the middle of the body is the female gonopore. In Cephalobus, sperm enter the female gonopore at mating, and embryos develop to the first larval or juvenile stage inside the mother. This female, who has a really nice pharynx, is carrying 3 or 4 young worms inside of her. This female is not in side view though, so we cannot see her gonopore or anus. I also caught some wild nematodes in moss my father collected for me in Sonoma County. After soaking it in spring water, I found lots of deltoid rotifers and also lots of these coiled anhydrobiotic nematodes. I'm sure that these are alive, but they did not become active in the 2 or so hours that I watched them. There are thousands of species of parasitic nematodes. Here's a nice large one, Ascaris sum, which as an adult lives in the intestines of pigs. This jar contains maybe 50 individuals. Here are a male and female individual. The male has that typical hooked posterior end. And here's a cross-section through an Ascaris made at the level of the pharynx. Ignore the little air bubbles that are developing in this section, which is really old. But in this section, you can see great cuticle, longitudinal muscles in cross-section, the dorsal and ventral cords, the pseudocoel, and of course the huge muscular pharynx. Dr. Ralph Appy kindly provided me some nice images of another parasitic nematode, Spirocamelanus pyrrhi, through its life cycle. This nematode is common in Southern California, where its final host can be any one of a number of bony fishes, mudsuckers, croakers, topsmelt, but others as well. Mated females release juveniles, which nematode people usually call larvae. Specifically, they release the first juvenile stage, which we can call L1. Copepods then ingest those whole, and they continue developing in the copepod. They molt into L2 and L3 in the copepod. Then when the copepod gets ingested by a fish, the L3 stage infects the fish. In the fish, L3 molts to L4 and L4 to adult. And then the adults mate and the whole business starts all over again. Here are some L1 juveniles or larvae just released from the mother. And here are some L1s happily living in their new home, the copepod Tigriopus californicus. Look at that long, skinny tail. That will change in shape at the molt from L2 to L3. Here are some L2s in the copepod. They're clearly doing some eating in there, as there is something in their guts now, and they're larger than L1s, of course. Here's an L2 that's just about ready to molt into L3. You can see that the new posterior end is not pointy like in L1 and L2, and you can see that that new posterior is pulling out of the pointy L2 cuticle, which is transparent but still visible. L2s also have a distinctive anterior end. L3s have two-pronged posterior ends, and they also have a distinctive morphology of the anterior end that's different from the L2. At this point, if the copepod gets eaten by a fish, the L3 can infect the fish. Once in the fish, it molts twice more, ending up as an adult that feeds on fish blood.